2014 has been a big year for crown rot. The eastern wheat belt has had a lot of disease. Farmers are reporting between 200 kilos and half a tonne yield losses. That's the sort of range that we hear. And everyone asks, well, this has come out of the blue, and you'll see in my talk what the mechanisms are. But basically, 2013 was a big biomass year, and we had a lot of inoculum. The summer was pretty dry, so there wasn't very much breakdown in the old stubbles, so that the fungus was displaced from the substrate where it was feeding. And then we had a lovely, fantastic break, which was warm and wet, and that favoured the disease. So that's basically in 3 points why it was very bad, followed by a very, very dry spring, and so the disease expressed, and we got the stress brought on the disease. So that's the background. So that's why we're trying to cover as much ground this year, letting growers know about what to do with crown rot. So, as Daniel says, we've got a national crown rot project. We've got the fellow on the right there is Stephen Simpfendorfer, and he's behind a lot of the work that we're doing in terms of bringing that experience from over east. My talk will cover management of crown rot by looking at the inoculum load, infection and expression in terms of what practical things farmers can do. So I'm using the word insidious, and this word for this disease is there, as I've explained. It's popped out of sort of nowhere, and the word is coined by Lester Burgess, who's the Fusarium crown rot expert. He's the Fusarium expert for Australia and has retired, but that's the way he describes this disease. It's what they call endophytic, so it just lays low and colonising inside the plant. It doesn't show itself up. You can't really see it until it just grows inside the tissue, and then when there's stress, it comes out and shows that it's present. So that's why it's an endophytic disease. So as you've seen before, we've got this big change in just between these years here in terms of the amount of inoculum, which we've measured by DNA. So from focus paddock data, we're definitely seeing a trend, and we're seeing it in other things as well, because there are samples that go to the AgWest plant laboratories, so you can see the trend there. So there's definitely more of the disease around. So as I said before, this year 2014 was a very bad year, came out of nowhere. But if you look historically, if you go even way back to the 20s, you actually see where the beginnings of this disease was. And of course, we've done a lot of minimum tillage. We don't burn as much as we used to, and the farming system is continuous wheat. So all those things together, not one thing alone, but all those things together have meant that the disease is persisting in the system, and once it's allowed to express by stress of low rainfall at the end of the growing season, at grain fill time, it says, ta-da, I'm here. So everyone who's an agronomist can go out and look and show farmers what's going on. It's a very easy disease actually to look at it in the paddock and distinguish it from the other things, as Daniel was saying. Some people get confused with take-all. You can see here on the right, you see the white mycelium in the pith of the stem, and of course the vascular tissue is what's invaded and causes the problem. And if you can bear with me here, you can see here that the infection is favoured by wet seasons, but the stress is actually the thing that brings on those whiteheads here. So in terms of the cycle of the disease, it likes the wetness of the early part of the season, and then when it's dry, that's when it actually shows up and actually is doing the actual damage, which is, of course, these whiteheads, as Daniel explained. So to follow on the theme from Stephen Simpfendorfer, who has put a lot of thought into what's going on with this disease, it's really about a balancing act. We've got the thing we talk about a lot, as in Roger's talk, about inoculum. We're measuring it with the DNA. We're worried about how much infection we're getting. We can be obsessed about this end of the business, but what I'm proposing to you today is that really the soil water at the end of the season is just as important. So you can't just focus on one thing and just forget about the other, This disease is complicated. There is no silver bullet. You've got to think about it in terms of this kind of risk management. And if you look at this trial results from Lang over east, this is Stephen's data, you can see the yield loss from the disease. And these are the rates of inoculum that are sown in. Daniel told you that with his trials he put stuff in that was at this level here, the higher level, where he's inoculating his plots. But as you can see, it ranges from 9 to 14 to 25% yield loss, and that is one aspect of it. You can see that is also a level across the 11 sites where some sites are actually quite high, not at this average. You can see the extent of the top end of the yield loss across that spread of inoculum. So you know that it can spread, and in this case at the 2 gram inoculation level, you've got over 50% yield loss. So it's not just at this level, it can spin out. And the reason for this obviously is this expression of the disease, and the conditions allowed this to happen. So if you look across all the sites that they had, you can see here from the one on the left, this was an irrigated site with minimal loss to crown rot. They all had the same amount of inoculum into the system, and you can see here it's over, it's 55% at this low rainfall site. So this is a gradient of rainfall from left to right, and so you get much more yield loss. So that order of magnitude is huge, and what I'm suggesting, and what Stephen is suggesting, is that that's bigger than the contribution which it can happen when you just move from, say, a low to moderate level of inoculum. So that's making a difference, but this stress business is the real killer in terms of the money, the actual number of whiteheads you get and how much yield loss you get. So just to give you a bit more perspective on things that can be done, technically you can see here with these treatments, this is a burning treatment along the bottom here. In 1991 it wasn't done, so you can see the difference. It's compared to just incorporation of the stubble or retained stubble, which are pretty much the same incidence of crown rot as measured in the plots. Now this is from a trial at Moree that was done by Lester Burgess many years ago, but it really does show that contribution which burning could do. Now, I'm saying a terrible word here, burning, so don't kill me straight away. You can take me out the back and quietly kill me later, but just let me say that it's reducing inoculum. It is making a contribution. It's not getting rid of the inoculum. It's whacking it down. So we know that this could make a contribution, and we've got to think very carefully about what we do if we were going to be burning, because you don't really want to. So what about cultivation? Another bad thing. I'm going to be murdered again. Cultivation's okay, but it breaks the inoculum, which is basically the bits of stubble that are infected. That's where it lives. That's its home. It spreads these little bits into smaller bits, so you're just making more points of infection. So you're increasing the chance of contact with the subsequent crop. And this is a figurative thing, thanks Stephen for the diagram. These red ones are the bits of stubble that are infected. These yellow mustard ones aren't. And you can see this is the points of infection. It's in this zone here and at the soil surface. That's where the contact happens between the bit of stubble and the emerging bit of plant tissue of your crop. So you're just making it worse by cultivating. So autumn cultivation could accelerate the breakdown, but it's unlikely to benefit in the year of doing it. So you'd have to have a break of non-cereal in order to get the benefit from breaking up that stubble so it could break down quicker. So you can't just do one thing, because you could just make it worse. And if you did it in conjunction with burning, that bad word again, sorry, and it had moisture and time, then it will help break down those bits. So it's all about breakdown of old stubble. This disease doesn't live off the stubble. It has to have the stubble to live. The old bits, the scungy old stubble you see in the paddock, you think that's actually a food source for this fungus. So you've got to get rid of it. So just to go back, because Daniel probably just skipped over that business there where he said, I'm going into off-row white sowing, and you probably thought, well, what's that? Well, the benefit is, the reason that works is because Backhouse's work over east again, which has shown the distance of the plants away from a source of inoculum. So he deliberately set up an experiment at different distances. And you can see the rapid reduction in incidence of crown rot in the crop because that was achieved. So when you go into row, you're away from the old stubble. And that's why in those trials we saw a difference. In this case, it's a large difference. So keeping plants away from the old bits of stubble is a good thing. So part of it's about having inoculum, but also about preventing infection. So when the inoculum levels are high, you need a lot of time to allow those microbes to break down the old stubble before you get it down to a level that's sort of acceptable. So you're getting the theme of my talk. There's not one thing here. Cultivation alone doesn't do it. Burning doesn't get rid of it all. Even sowing off the row won't completely keep you away from old stubble. But those things together would make a difference. So we've talked a lot about break crops. We've got crown rot inoculum levels declining during break crops. That's our experience from trials that have been done all over Australia. And the rate of decline depends, as I say, about that breakdown of stubble. So the quicker that stubble breaks down. So therefore, thicker crops with bigger canopies that obviously get wet during the growing season, they'll be ones where that old stubble will break down. So if you use a chickpea crop over east, not a good break crop for breaking down crown rot stubble because they don't form enough of a canopy, just piss weak. So canola crops, a lot with a canopy. But again, the understory, it has to be wet underneath because otherwise it just won't break down. So in terms of the sharp end, what farmers could be doing, obviously knowing where your crown rot is and doing your predictor B tests, going where there's more stored water on the farm, if you can get summer rain happening, obviously they're lower risk. Making sure these constraints, we talked a lot about constraints during just this first day, and you can see about how all those interactions could be happening with anything that's restricting the crop's ability to get hold of water, because that means it'll be more stressed. So it's more stress. So if it's infected, then it will have a problem and it'll express the disease. So root lesion nematode could be a problem. There's nothing saying we couldn't possibly be having crown rot and take all together in paddocks and we're just not picking it up. They are different in their distribution, but that could happen. And any of these other diseases. And obviously, if you're trying to cultivate or bury stubble close to sowing cereal, that could be dangerous because you're just creating more inoculum. And effectively, that's happened to us with our own paddocks on the Meriden Research Facility. So we're dealing with it ourselves. Glenn's here. He's lost all his hair because he's worried about crown rot. So in terms of more the management options, the big thing which I wanted to reiterate was just about reducing the risk of the crop having water stress. And last year's experiences where paddocks had lots of empty heads and where they didn't were often on the basis that that crop was flowering at a time when there was less stress. It happened before the hot winds of late August when we all went to Darren Field Day, and it was really the season turned very bad. So there's a lot of crop that it just dodged the bullet. Infection, they all got infected, but they dodged the bullet because they just didn't get stressed. There was the right flowering time for that particular variety and the window. So there's a complete match. And so that's why some paddocks had it bad and some paddocks didn't. As I said with that earlier graph where you could see the big impact of stress on the amount of actual disease that you got. And the other one, which we don't talk about enough, if you actually over-fertilise with nitrogen, you can hay off a crop. Cereal crops, that can happen. And if you hay off the crop, you're going to be at higher risk for crown rot. So saving your money, only putting the nitrogen where it's really needed, being very judicious, not too high seeding rates, keeping your seeding rates just sensible. Anything that causes haying off would be expected to cause more crown rot. Fungicide seed dressing. Rancona Dimensions is registered for suppression of crown rot. There isn't much data for WA. We are hoping to do some trials this year. The general consensus is that we would expect it to be useful as a part of an integrated management package and not to be relied upon itself. Again, it's helping on one end of the business on that balance between inoculum and water. It's really helping prevent the crop being infected. And if you can help the crop be less stressful, then that's obviously probably a better benefit. So you just got to put it in perspective. It's not a silver bullet. And just something for everyone to do, if you're a farmer, to work with your agronomists. Agronomists, this is the tips to work with the farmers. The sort of areas, if you're just doing surveillance, you're trying to get ahead of where it is and where it's coming in first. It's often areas around trees where the stress comes in early, and so you see the basal browning very badly. Again, I come back to this word insidious. In season with good soil moisture, the colonisation is mainly inside, so it's endophytic. So these infected plants could still be present and you won't see basal browning or any of these symptoms, but they are still actually infected. So the one on the right here is actually a source of inoculum, believe it or not. So this is the one that's got the traditional classic basal browning. This is infected, but it's actually got plenty of the fungus growing inside of it, and that fungus will just either increase or the amount of inoculum that's in the system. So don't be fooled if you think you've got this situation, which is really like a 2013 scenario. Paddocks in WA were all like this. They were infected, but it didn't show. There was nothing there to say you got crown rot. Because you grew so much biomass, there's just more of it to live on. It's more build up. This is the thing that can catch people out. This is why we dropped the ball a bit this year and really didn't focus on what actual levels we had. It snuck up on us. So this is infected as well. And then, this is future infection. We know this, but it's just a thing about if you've got this scenario in a whole paddock and you think you're free and it's a safe one to go and put wheat and barley on, this is where the DNA test comes in. You've got to get some idea of how much infection you've got, how much inoculum. So don't be misled. The subtle residues of symptomless plants maintain or increase inoculum levels. So just because you don't get whiteheads doesn't mean you don't have the inoculum there. So you all know this. Predictor B, just so you know, the more modern version of the predictor B for crown rot is where we spike with a piece of stubble. So we absolutely know we're picking it up. So it reduces the risk of failure to warn, but we could get, which is a really good thing, but it increases potentially the false positives, if you know what I mean, because we're targeting the areas where the infection is. So we're sort of skewing our sampling, but we're definitely not going to be in the situation of saying, oh, we've got a test back and we didn't find it and it come back negative, so we must be okay. So you're skewing it to make sure if that fungus is there, you're definitely picking it up. So that's why if you do your DNA test and you get your AccuProbe out and go, we ask you to go in the rows where the infection is and to put pieces of stubble in on every soil sample. So that means it's spiked, and so you're not going to miss it if the bloody thing is there. Just so you know what's going on, Stephen Sempendorfer's work over east has related the amount of DNA that we pick up here at sowing with the amount that you end up at harvest in terms of actual infection measured in the lab, a real thing. So that's a pretty good, by our kind of work with DNA, this is a pretty good relationship that's got good statistical evidence that there is a solid relationship. So that means we can say if you get a really low level of DNA back, then you know that you're on this end of the infection. This is the amount that your crop would get, so you're safe. So knowing that this is a pretty solid sort of relationship means we know we're down here with our level of DNA we picked up, then we're going to be safe. We're going to have lower which is a good thing to know. So it does work. So my key messages are really that crown rots measured by Predictor B is definitely on the increase, as you can see from all the evidence and other evidence. The inoculum levels and this infection can be managed, break crops, judicious intervention to get rid of that inoculum. But just remember, making sure your crop is less likely to be stressed at grain filling really makes a big difference, arguably the biggest difference in the actual impact in dollars in the bank from whiteheads in your crop. You'll get less whiteheads if you've made sure your crop is filling grain early. Early the better. And I know for some people they're going to say over beers, you've forgotten about frost, but there's a whole bunch of the wheat belt where people do manage this quite well, and it's why some people actually say, I won't be growing emu rock, I'm going to go with mace, I'm going to make sure it doesn't get stressed, because as Daniel showed, it out-yielded emu rock where the disease wasn't coming through. So that's something for you to think about over a beer. So thank everyone that's helped. It's a big project, lots of people everywhere, lots of helpers. It's much appreciated for me and the team, so thank you.